guys, so let's talk about 15.2. You have the notes, so I'm just going to do a couple of quick examples. The two things to do for 15.2 is finding arc lengths from degree measures. So we know that AB is 180 degrees, but we need to find the actual physical distance between A and B. That's what arc length is. And then we'll also be converting degrees into radians. I'll show you a little shortcut to do for that. So finding arc length, let's find the length of AB. Here's our formula for turning our degree measure of our arc into actual arc length. So here's where our radius goes, and here's where the measure of our arc goes. So S, which is our arc length, is the degree measure of our arc, which in this case is 120 degrees over 360 times 2 times pi times r, which in this case is 3. Let's go ahead and reduce this. 12 and 36 is 3, so we've got 3 1/3 times 6 pi. Just went ahead and multiplied those together. So we've got 1/3 times 6 pi is 2 pi, because 1/3 of 6 is 2. And you know your online homework is real specific about how they want this. They'll either want you to leave it like this with pi as your variable, or they're going to want you to use, they'll either give you the fraction of pi to use or 3.14. They'll be real specific about how they want you to do it. Okay, so now I'm sure you guys can apply a formula to this. So now I'll show you a little shortcut to apply this same formula up here, a little shortcut version of it when converting degrees to radians. So let's take a look at our formula real quick. So when converting degrees to radians, we can always kind of assume that we're dealing with the unit circle, because when we convert our degrees to radians, that's what the radians, the base of the idea for radians is the unit circle. And we know that the radius of the unit circle is always 1. So let's kind of take a look at what happens when we just put 1 as our radius into this formula and then reduce it. So we have our measure divided by 360 times 2 times pi times 1. Well, we can get rid of the 1, right? Because 2 pi times 1 is just 2 pi. And then when we do our reducing, we can reduce this 2 and this 360 to 180, and our measure over 180 times pi, well, our pi can go on top too. So basically, this is pi over 180 times our measure. Right? All we did was move the m down and the pi up. So now, whenever we're converting a degree measure into radians, all we do is multiply that measure times pi over 180. I'll show you what I mean. So when converting 90 degrees to radians, let's use our little shortcut formula. So whatever our degree measure, we're going to multiply by pi over 180. And that's going to give us our radians for that degree measure. So 90 degrees to radians, we take 90 and multiply it by pi over 180. Let's go ahead and reduce. 90 goes into 180 twice. 1 times pi over 2 gives us pi over 2. That's it. We did it. And if you remember your unit circle, remember 90 all the way up, when counting by radians, we go, we start with 0, and then when we get up to 90 degrees, that was pi over 2. We get out to 180, that's pi
Mommy.
Okay, bye. You want me
Please.
to- Okay, sweetie.
This is here, Mommy.
Okay, I will. Okay, so let's go ahead and apply the same formula when to convert 45 degrees to radians. Same thing, we take our degrees and we multiply it by pi over 180, and that will convert our degrees to radians. So 45 times pi over 180. How many times does 45 go into 180? 4. So 1 and 4. 1 times pi over 4 is pi over 4. And if you remember our unit circle, that 45 degrees, that halfway point in between 0 and 90, that was our 45 degree marker, which was 1 pi over 4 or pi over 4. Okay, I think you guys have everything you need to finish this up. If you have any questions, shoot me an email. If you're unable to make the tutorials, that doesn't mean that I won't video conference you to go over homework questions with you. So let me know if you like learning like this better. I could set up tutorial sessions outside of the normal scheduled time to help you guys. Just let me know. Bye.